All right, today's example, we're in Unit 4 for AP Chem, and we're going to do a redox example that is under basic conditions. And how do I know it's a base? Well, remember, all bases always end in hydroxide. So I can look at this one and I go, oh, this is a basic one, and it's exactly like the ones we've been doing normally. The acid ones are just the normal examples we've been doing. It's only at the very bottom that we make an adjustment. So let's just go through the problem. First steps always, figure out the charges of everybody. Aluminum is a 0 here. 8 oxygens, so that's a -8, but we have a negative charge of the polyatomic. So chlorine must be a +7. So it's going to go from a +7 to a -1. We're going to have a change of 8 electrons there. And aluminum is going to go from a 0 to a +3. So our first step is write the half reactions. And remember, we've got Leo goes Gur. So we have chlorine is my reduction one because it gains electrons. Remember, it gained 8 electrons in this case. So this one gained 8 electrons. Our oxidation one was the aluminum because it's going to lose oxygens. So it went from a 0 to a +3. And this was a loss of 3 electrons. Now we need to balance the elements. Well, and we're just talking about the ones that are being reduced or oxidized. We're not worrying about the oxygens of hydroxide. We take those later. So the chlorine is the same. The aluminum is the same. I don't need to do anything there. Now balance the oxygens using water. So I do have oxygens here that I need to take care of. I've got 4 on this side. If I have water, it's just H2O, so I'm going to have 4 waters with it. So this becomes here I've got 4 oxygens on the product side. I have none on the reactant side. So again, I'm going to add 4 waters on the reactant side. Now we balance with hydrogens. We balance the hydrogens with this. And I have 8 hydrogens here because I added the water in. I've got none on this side, so I'm going to have to add 8 hydrogen ions. And it's the same steps here. Here I have 8 oxygens. Here I've got 4. So I'm going to have to add 4 more hydrogens to this side. Now I need to balance my plus and minuses with adding electrons. So let's go. We got 8 plus here, -1, -1. So I've got a +7 on this side, a -1 on this side. So I need this to be a -1 on this side. So I'm going to add 8 electrons. So now it'll be a -1 on the product or reactant side. And here I've got no charge. And here I've got a +4, a -1, so I'm going to have to add, I need to get it to 0 to balance out because I have a +1, so I'm going to have to add 3 negative electrons to the product side. And here and you got to be careful not to lose my superscripts, that I have those charges all the way through. Now I need to balance the number of electrons I have between the reactions, between my reduction and my oxidation. I need to balance those out. I've got 8 and I've got 3. Well, there's no easy number between other than multiplying by the whole thing. So I'm going to have to take everything here times 3 and everything here times 8. And now I want to make sure, because I'm going to combine them, I want to make sure I have my 2 arrows, my yield signs lined up. Again, I'm just looking for ways not to make silly mistakes. So 3 times everybody, I've got 24 electrons, 24 hydrogens, and then I've got 3 chlorine ions, and now I have 12 waters. 8 times everybody, so now I have 32 waters, 8 aluminums. I'm going to have 8 aluminum hydroxides ion plus 32 hydrogens plus 24 electrons. Now I need to combine, and I know I'm doing things right because my electrons disappear, and I'm looking for anything else that I can do. Ooh, I can get rid of all of these, and this will change to 20, and I've got 32 hydrogens here, 24 here, so I can get rid of this, and this will go to 8. So this all reduces down to 20 waters plus my ion. And sometimes it's kind of easy to circle all these to make sure that I've actually included them. It's really easy to miss something. Whoops, and I almost forgot my 8. See, it's easy to make a mistake. All right, so here comes our new step. Because it was a base, we need to get hydroxides back in. So we're going to balance my hydrogens with hydroxides. And since I have 8 here, I have to add to both sides 8. So I'm going to have 8 hydroxides plus my 20 waters but when I have my 8 hydroxides plus 8 whoops, plus my 8 hydroxides, that's really 8 waters. So this is going to go to 12. So now my real answer it's a lot of little steps. It's really easy to make a mistake. So take your time and do it. But the nice thing is we can double check at the end. We always want to double check that my charges on both sides are the same. So I've got a -8 here, a -3, so that's a -11 total on the reactant side. I've got a -3 here. And, ooh, see, I would have missed, I would have lost. Easy to make a mistake. I lost that, but now I have 8 of those, so I caught myself. Both sides have a -11. I feel pretty good that my answer is correct.